everybody, and welcome back to Atman Unlimited. Let's talk coolant. Coolant can be a very broad and confusing topic, especially if you're trying to get into a home shop. Now, there's two types of coolant and lubrication used in industry. There's straight up oil systems, and then a lot of shops are using what they call water miscible coolant, or oil-based coolants that will dissolve in water. I don't feel that 100% pure oil-based system is going to be good for a home or small shop. You're probably not going to be doing jobs that require that type of lubrication. Oil is typically used in applications that require a lot of hard cutting and very high cutting forces. It's also harder to deal with, harder to clean up, harder to dispose of, because it's a 1-to-1 ratio. If you have a 35-gallon sump, you need to bring in 35 gallons of oil, and then you need to dispose of 35 gallons of oil. So I don't feel that anybody in a home shop or small shop should look at a pure oil-based coolant. It's up to you. You have to decide what's best for you, but in my opinion, I don't think you're going to need it. That brings us to the other type of coolant, which is water miscible coolant. And in this family of coolants, we have two ends: pure oils and natural oils, and then fully synthetic coolant, and then there's the mixture of semi-synthetics and oils mixed together in the middle. And the amount in different types of coolant and different manufacturers is immense. So just off the top of my head, the biggest coolant manufacturers that I see most used: Qualichem, Hankstofers, Blaser Swiss Lube, Houghton. So those are the big ones that come to mind that you see a lot in industry. Now, me personally, I like to use Blaser Swiss Lube, and I like to use a mineral oil natural based coolant. And when I was making my coolant decisions, I had two main goals. One is I want the human interaction with the coolant to be nice and pleasant. I want it to be nice on the skin. I want it to be odor-free. And then secondly, I want it to make good parts. I want good cutter life. I want good machine finishes. So those were my two main selecting factors for coolant. Now, a lot of the synthetics and semi-synthetics, they're used more for exotic materials and more aerospace applications. The problem with synthetics and semi-synthetics is they typically are a little bit harsher on the skin, in my opinion, in my experience. So I steered away from the synthetics and semi-synthetics, and that's why I went with the natural mineral-based coolants. Now, the reason why I went with Blaser Swiss Lube, and I specifically use Blazo Cut 2000 Universal, is because it has almost no odor. And the odor that it does have is pretty pleasant. It kind of smells like almonds. So I don't mind being around it. When I'm in the shop all day and I walk in the house, the missus doesn't go, "Oh my God, you stink." Okay, it does not have a strong odor. It's not offensive. The nice thing about Blaser Swiss Lube, again, is that it's soft on the skin. If I get it on my hands, it's not a big deal. I don't get a rash. It actually makes my skin pretty soft if I get a lot of it on my hands. So that's a big benefit in my mind. Because also, no matter what you do, you're going to be inhaling some of this stuff. So if it's giving you, rashes on your hands, or it's rough on your hands, think about inside your body. And if you say you don't inhale it, you're lying to yourself. Because no matter what you do with coolant and what you do with ventilation and exhaust systems, you're going to end up inhaling some small amount of it. So those were my choices with Blaser Swiss Lube. Now, along with the cut quality, the tool life, and the human factor, you also have the maintenance factor. So the Blaser Swiss lubes are pretty much maintenance free. You keep them topped up, you keep your concentrations good, and you keep the coolant moving, and it's going to last a long time. So I've had this batch of coolant in my tank for about 18 months, and it's just now starting to drop its pH a little bit. It doesn't have an odor to it, but you can tell that it's getting a little bit tired. So I'm going to be switching it out soon. But it's that ease of maintenance and longevity that, also steered me towards the Blaser products. Also, your availability for coolant can weigh in your decision. So the supplier for Blaser Swiss Lube is about an hour away from me. I can call them up and I'll have, 5 gallons the next day. So that's a benefit to me. You may want to contact your distributors and find out which coolants they carry, and then see if you can get some samples or try some different coolants and see which one you prefer and you like. So once you nail down what type of coolant you want to use, and again, I'm just giving you generalizations so that you kind of have an idea of what to go research on your own. We could stay in here for hours and talk about all the different machine coolants. So once you decide on your own what type of coolant is best for you, let's talk about some of the general rules and how to get it mixed up and how to maintain it. So first, let's talk about mixing. And I see a lot of people, especially on YouTube, make some crucial errors in mixing coolant. The first rule is never ever mix coolant in your sump. You never want to do that. You will not properly mix it. The second major rule is that you want to mix the coolant into the water. Don't mix the water into the coolant. Now I'm going to put a diagram up here on the screen. What happens when you mix coolant is you generate little tiny bubbles of oil. The way that this works is there is what's called an emulsifier in the oil, and that acts like a glue to help the oil stick to the water. Because normally oil and water want to get away from each other. They don't want to be together. The emulsifier helps them stick together. The emulsifier surrounds little droplets of oil that then float around in the water. If you don't mix your coolant properly, what's going to happen is you're going to get big globs of oil and big bubbles of oil. The coolant's not going to perform right, and it's not going to stay in suspension right. So it's very important that you mix your coolant properly. If you mix your coolant wrong and then send it off to the manufacturer for analysis, they will be able to exactly tell you that, hey, this coolant you mixed wrong, and then if you send in another batch that's mixed correctly, that one's mixed correct. Because they can look at the oil droplet size suspended in the water and tell you how good a job you did. Now, most professional places, they're going to want to mix the coolant with a Venturi system, because that provides a lot of agitation and a lot of force to really break up the concentrate into the water and get those small, tiny droplets of oil floating around in the water. That's not really practical for a home shop or a small shop because those Venturi systems are pretty pricey. The best way that I found to mix coolant is I mix it in 5-gallon batches with just a 5-gallon bucket, and then I use a paddle that's normally used to mix cement or grout. And what I'll do is I will get the water going really good and nice and turbulent, and then I'll slowly pour the concentrate into the water while it's being mixed in turbulent, and then I'll keep it mixing in turbulent for a little while after all the coolant's added in to really help break up that concentrate and get that small bubble size. Okay, you want small little droplets of oil. The type of water that you use is generally not that critical. It's not as important as people think. The coolant manufacturers specifically formulate and design the coolants to be used with general city water. So unless you have a water source that has really hard water or extremely soft water, you can just use standard everyday tap water. You don't have to use distilled water, you don't have to use specially softened water. You don't want to use softened water or you're going to have foaming problems. So standard city water is the way to go. It's what the coolant was designed for. If you do have some concerns, you can talk to one of the coolant representatives and then they can guide you appropriately. So that's how we mix our coolant and then get it in our sump. Now, once our coolant is mixed and in our sump, now we have to go into a maintenance mode. And you're going to need two main things to maintain your coolant. The first thing is going to be what's called a refractometer. Okay? So this is a refractometer, and this is what it looks like inside of a refractometer. This uses what's called a Brix scale. And basically it's a way for you to measure, for a better term, the density of the water and to see how much stuff is in it. Now when you use these, you want to first put pure water on it, a distilled water source, and then you can look inside it and zero it out. If you notice there's 0 and then this one goes to 10%. So you want to zero it out, and then once it's zeroed out, now what you do is you take a little sample of your coolant and you put it on the prism, and then, then you can measure your concentration of coolant. So when you're using your refractometer to measure the concentration of your coolant, you have to refer to your coolant's manufacturer's spec sheet. And in that spec sheet, they may list a correction factor that needs to be applied. So they know what kind of refractometer you're going to use with the Brix scale. And some of the coolants don't correctly correspond to your percent concentration on a Brix scale. So there's a correction factor that you can use. And what you do is you take the percentage that you measured off of your refractometer and then you multiply it by that correction factor. And that correction factor may be a little bit above 1, it may be a little bit below 1, and then that will give you your true percentage concentration of coolant. Now, the nice thing about the BlazoCut 2000 Universal is it has a correction factor of 1. So we don't have to do any math. What you read on the refractometer is the actual concentration level of the coolant. So that's another nice thing about the BlazoCut 2000. So this is very important to have to maintain your proper concentration of coolant. So what's going to cause your coolant concentration to change? Well, there's a lot of water in it. It's mainly water. Most coolant concentrations, depending on the manufacturer, are going to range somewhere between 5 and 10%. So the other 90% is water. The water is going to evaporate. As the water evaporates, your concentration goes up. If the concentration goes up too high, then the coolant won't stay in suspension correctly. So this is important for maintaining your concentration. The second thing that you need to have is you need to be able to test the pH of the coolant. So the coolant will have natural buffers in them to maintain what they call alkalinity. And it's that buffer and alkalinity that keeps the pH balanced in the coolant. As the coolant ages and as you make more cuts and you get a lot of chips in the coolant, your pH is going to start to slowly drop and degrade. If the coolant goes too acidic, that's when you start getting rust problems and all kinds of issues in your machine. So it's important to monitor the pH of your coolant every once in a while. This is easily done just by visiting your local pet store that sells fish supplies or your local pool store that sells pool supplies. Because just like a swimming pool or a fish tank, you want to measure the pH there, it's the exact same thing here. So I use little test strips that I would normally use in my fish tank in the house, and these work just fine. They're about $10 for a bottle of 25 of them or so. Okay, so measuring the concentration of the coolant and then measuring the pH of the coolant to maintain it is critical. The last maintenance item that we need to worry about and address is oil skimming and keeping the coolant mixed up and moving all the time. Now, especially if you have a machine that has an automatic oiler on it, that machine is going to be putting oil into the coolant. And that oil won't necessarily dissolve into the coolant with the emulsifiers. It's going to float on top of the coolant and act as a layer to seal the coolant off from the air. And this is very bad for the coolant. What's going to happen is that if the coolant gets sealed off from air by a layer of tramp oil from the whey lubes, from the whey oiler, all of the aerobic bacteria and beneficial bacteria that live in that coolant, they're going to die off. And then what's going to replace them is what's called anaerobic bacteria. Anaerobic bacteria are bacteria that don't breathe oxygen. They're the bacteria that make hydrogen sulfide. And hydrogen sulfide is what makes coolant go rancid and absolutely stink. You do not want this to happen. It is awful to clean up rancid coolant. The best and easiest way to combat coolant rancidity is to keep it skimmed well all the time and to always keep it moving and have oxygen in it. That way you maintain the beneficial or good bacteria in your coolant, and then you won't get anaerobic bacteria growth. Now, oil skimmers can be pretty expensive, but if you think a little outside the box, you can make one pretty cheap. So this is the oil skimmer that I use. All it is a Rubbermaid bin, and then I cut a couple of slots in the side of it, and it works exactly like you would see for a pool skimmer or a fish tank skimmer. And then I went to the fish store again, and I bought what's called a power head. Basically, it's just a little tiny submersible pump, and I drilled a hole in the bin, and the power head will pull water or pull coolant from inside the bin and push it out of the bin. So what that does is it forces fresh coolant from the surface to flow in through the skimmer, and then the oil will collect inside the little Rubbermaid bin, and then it shoots the clean coolant out the bottom through the pump. And this serves two purposes. One, it skims off all the oil from the tank and just leaves it on this little tiny patch inside this bin. And two, the turbulence from the pump constantly keeps the coolant moving. It keeps it oxygenated, it keeps it emulsified and mixed real well. So that's how I get the long life of my coolant, is by constantly keeping it moving. Even if my machine sits for a week and I don't make any parts in a week, my coolant is always moving and it always stays mixed and oxygenated. So that's how I get my long life. And this entire oil skimmer cost me about 20 bucks to make. So it's not very expensive, it was really easy to make, and it does a great job. And then once a week I just come in the shop and I'll just take a little piece of plastic or a card and just skim off that little tiny patch of oil that collects. It's very easy to maintain. So now you've got your coolant, you're monitoring your concentration, you're monitoring your pH, you've got to add some top-off water. What we don't want to do is we don't want to pour pure water into the coolant mix. What we want to do is you want to mix up a small batch of very dilute coolant concentrate. So you want about 0.5% to 1% mixture of concentrate to water that you then can add to your sump to top off. If you just pour pure water into the coolant, the emulsifiers don't like that. You all of a sudden have this surge of extra water particles floating around. Where if you premix a little bit of concentrate in there, it puts emulsifiers in that fresh water, which then start binding up with the oils, and it makes so that when you add the low concentrate mix in with the main coolant, it doesn't disrupt the suspension of the oil in the water. So that's a critical point. You don't want to ever add pure water to your coolant sump. You always want to mix up a dilute concentrate to then pour that in to your coolant sump. So now that we've used our coolant and our coolant reaches its end of life and it's time to dispose of it, this is also where the water-soluble oils come to shine. Now, do not dispose of machine coolant, especially water-soluble coolant, down any sewer or drain. One, it's illegal, and two, it wreaks havoc on your municipality's sewer system. They're not designed to be able to filter out oil that can mix with water. Okay? They cannot do it. It's going to mess up their equipment. You will get in major trouble doing that. However, because it's mostly water, what we can do is if we leave it in a container just like it was in our sump, that water is going to evaporate off. If you warm up that mixture and raise the temperature of the water, it's going to evaporate off pretty fast. So you can easily take, 10, 15, 30 gallons of coolant, evaporate off a very large portion of that water, and then end up with 5 or 10 gallons of concentrated coolant waste left that then needs to be disposed of. So you can greatly reduce your waste volume, which will then reduce your disposal costs just by letting some of the water evaporate off. So when you're all done with your coolant, you can drain your sump, put it in a container that's safe, and then let some of the water evaporate off, and then you can dispose of the more concentrate coolant remnants. But you must properly dispose of your coolant. I hope that sheds a little bit of light on the machining coolant realm and some of the decisions and choices you have to make, and also some of the proper procedures for mixing and maintaining machine coolant. If you have any questions, again, please feel free to comment below or send me an email, and we'll see you on the next video. Thanks for watching.